Good morning, everyone. Thank you so much for joining. Can we have a volunteer to lead us in a word of prayer? Okay. Yes, Mark.
Let's humble ourselves for a prayer. Heavenly Father, you're so good, you're so great. There is no one like you. We thank you for this blessed morning. We thank you that you have enabled us to wake up. Who are we that are still alive and are able to attend such glorious lessons? Heavenly Father, we pray that you bless us and enable us to understand each and everything that we are going to learn. We pray that you give us the Holy Spirit to help us interpret each and everything with glorious wisdom. We pray that you bless our teacher in each and everything. In Jesus' name I've prayed. Amen.
Thank you so much for the word of prayer, Mark. Dear friends, today we are going to look at the theme of data and probability. And our topic today is going to be probability. Like many of you requested last week that we can start with probability. So the whole of this week we shall deal with probability. And then the other week we shall start on linear programming. And the competence, what you are expected to know by the end of this topic is that you must be able to solve a wide range of problems concerning probabilities. So we shall do quite a number of problems on probability, more so when it comes to word problems, but also we shall be applying the knowledge in other topics such as in data collection, such as in set theory. You'll find that the knowledge of probability will be needed. Then for this particular lesson, our major areas of concentration are going to be on understanding what we call a random, what we call an experiment, what we call an outcome, what we call a sample space, event, and then probability. But also, we should be in position to know how they construct what we call the probability space. So those are the things that we are going to concentrate on. And once you understand them very well, then all other numbers that you will be meeting concerning probabilities, they will be easy because these ones are the foundation for anything else that happens within the probability space. Okay, then we have keywords. Maybe let me ask you can write down these keywords that we are going to be looking at. Let me know when you finish. Okay. I have a starting question here. Have you ever used these words in daily life? Any of these words that are on your screen? In case there is any word that you have ever used, feel free to share either in the chat or you can raise your hand and you share with us the circumstance where you used that word and maybe you share with us a situation. Okay, yes, Mark.
Yes, the first word, likely. Most cases you can be like, it is likely to rain. And then that means you feel there is a possibility of it raining or it may actually not rain. So you just say it is likely to rain.
Okay, perfect. That is one, likely. Any other person? Thank you, Mark. Any other person who has used any of those words? Likely, probably, hopefully, by chance, certainly, surely, and under what circumstances have you used? And by the end of this topic, I'm sure you're going to know when you need to use such words and where they can apply. Now, take an example like Mark has told us, it is likely to rain. So the moment you use that word, it means that chances are high it is going to rain. So whenever your probability is above 0.5, there you are almost sure that it is going to rain. So whenever you use such words like likely, it means that the chances are very high, about 80% or 75% that it is really going to rain. So that means you are almost sure that something is going to happen. But when you use unlikely, then there you are sure something cannot happen. Yes, Paul.
Mm, also, maybe where may say that maybe she will come, which means it's a half probability. You're not sure if the person will come or if she may not come.
Okay, perfect. Thank you, Paul. That is true. So many of these words you are using them in your day life, and whenever you find yourself using such words, it is an indicator that you are either sure, not sure, or you don't know where you lie. So whenever someone uses such words, it means that someone is operating on probability. So chances are he may either appear or he may not be able to appear. So you are not certain where the person is. So that is where we can use the okay. Yes, Rima.
Okay, like the word certainly. Many
Mhm.
people use certainly in cases of like when you're exactly sure that what you're saying is going to happen.
Okay, perfect. Certainly, for certainly, it is a sure deal. You know something will happen. Take an example. I'm very sure or I'm very certain you are going to sit your exams in October. Come what come may. So that one at least I'm very sure. I'm very sure that the senior four papers, they have finished marking them. So that one I'm very sure. So whenever you are sure about something, then it is okay to use the word certainly. So certainly corresponds to a probability of 1. And whenever you meet 1 in probabilities, it is an indicator that you are sure that thing will happen. Okay, good. So those are some of the words. Someone is saying she got this job by chance. Yes, so that one is also very true. By chance. Okay. Probably maybe someone was not fit for the job. Maybe it was through luck. Yes, so all those words indicate that we are applying probability in our daily life. I have a scenario here. Someone can read for us and then we think about our response. Yes, Rima.
Scenario: you are at a school sports day and the final 100-meter race is about to begin. One of the participants, Alex, is a well-known sprinter and has won all his previous races this year. Basing on his performance, many believe Alex is not guaranteed to win this race. However, there is still a small chance, about 5%, that Alex might lose due to his false start, an injury, or another unexpected factor. Task: would you place your bet on Alex? Will you place your bet on Alex winning? Would you bet on the likely chance of someone else winning?
Okay. Do we have people who want to respond to that task? Let me look through the chat. Which side would you take and why? Yes, Amara? Which side would you take?
Teacher, good morning.
Good morning.
Teacher, me, I think I would take maybe the unlikely chance of someone else winning.
Okay, why?
Because as you are saying now, when you go into the second paragraph of the question, it's saying that, however, there is still a small chance, like about 5%, that Alex may lose due to a false start or an injury. So I would say in the probability, in the circumstance of him winning, someone else may have the chance of winning because of some circumstances of him either getting into an injury or him having a poor start.
Okay,
That is
thank
my
you. Yes, Mark?
Remember, we are placing a bet, and the chance of Alex losing is only 5%. So you realize that the most chances or the highest number of chances are that he is going to win. So for me, I would place a bet on the fact that he is going to win because the chance of him losing is only 5%.
Okay, thank you, Mark. Gift, I saw your hand up.
Good morning, teacher. I just wanted to say what he exactly said previously.
Okay. Okay. Now, whenever we are coming up with our decision, or before you make a decision in probabilities, I want you always to take note of this, that this is 0, this is a half, and this is a 1. This is what we call a probability scale. This one, this is what we call certain. This is what we call uncertain. This side, we shall have unlikely, while this side is where we have likely. Now, any probability above a half, take an example here, we can have maybe 75, okay, or I can use 3/4. Anything here, I can have maybe a quarter. So anything that will go beyond a half, that one chances are high. Even when you look at the percentage, in percentages, a half is 50, 3/4 is 75%, this is 50%, and this is 100%. Then this is 25%, and then this is 0%. Now, when you look at the chances of Alex winning, because the chances of Alex losing is just about 5%, meaning that chances of him winning is about 95%. So when you look at the 95%, you are not saying that 95% is on the side of the likely. So you are almost sure that Alex can win that race. So when you are putting your bet, meaning since the biggest percentage lies in almost the certain part, then the best decision or the best bet would be that you are almost sure that Alex can win that race. So that is how you make your decision. You look at the winning chances. What are the winning chances? Because when you look at 5%, 5% of losing is a bit very minimal or very low. So it will depend on a lot of things, maybe the people he is in the competition and the rest of the factors. But that is what you base on when you are coming up with a conclusion. Okay, yes, Paul was saying, I think I would put a bet on Alex because he has more experience and is only 5%, but the remaining 95% is that he will win. Okay, thank you. That is correct. Okay, I have another one scenario here. Someone can read for us and then we answer it. Okay, yes, Paul.
In a football match, Team A has been dominating, but possession and creating numerous chances. By the 85th minute, they are leading 3-0 against Team B. Statistically, Team A has 95% chance of winning, while Team B has only 5% chance of making a comeback and either drawing or winning the match. Question: as a fan of Team B, would you still believe in the probability of a comeback, or would you accept the match is essentially decided?
Okay. Those who are supporting Team B. Okay, Paul, do you want to come first?
No, sir.
Okay. So you can start with Rima.
Okay, sir. I think I support Team B. Yes, I'm the fan, but also, though there is a low percent of me winning, this is a chance which it's a possible chance. It's only 5%, but it can happen. So I still believe there's a possibility of my team having a comeback, or we can draw or have a better win than losing 3-0.
Okay. That is okay. Chisache and then Amara.
Yes, as a fan of Team B, I would still believe in the possibility of the comeback because, yes, as she said previously, there is still a 5%. You notice that some cases it can look as if it is likely to rain, but then unfortunately it doesn't. So even in this very case, you can lose hope, but because of this 5% possibility, things happen sometimes. So I would not lose hope unless the match is done. So because of the possibility that is still in existence, I would not lose hope. I would still believe in my team. Miracles can happen.
Okay. Amara. Thank you, Chisache.
Teacher,
Mm.
teacher, to my ideal,
Mm.
I don't believe Team B would win.
Mm.
Because first and foremost, because even in the question, it's saying that by the 85th minute, they're leading 3-0. So depending on whether they have added extra time or they haven't, in actual sense, there can be a possibility whereas that in the match, they've added like about, let me say, 5 minutes. And basically they're remaining with 1 minute, and the chance of scoring back any goal may be possible. They may score maybe one back, but to win the match, to have a great comeback, they wouldn't come in really. So in my bet, I would say that Team B wouldn't win.
Okay. Then lastly, Pearl.
I
Thank you.
also think that Team B does not have a possibility of a comeback because it's a 95% chance of them not winning. So the 5% is not all that big. And also the time that is remaining is not going to be enough for them to get back because it's a 3-0. So in other words, I'm also supporting Amara.
Okay, okay. Thank you. You can transfer the same knowledge when you are in an exam. Just imagine you have about 5 minutes to go or to end the paper, and you have about maybe three numbers you have not done. Do you feel you can do them and finish, or the time may not be enough? Now, those who support soccer, sometimes you complain a lot when maybe the VAR, that is is it virtual assistant referee, when they do not award some offsides. Sometimes you may look at it as if it is an offside, but there is some kind of probability that is always applied. So it always depends on the probability that they can say now it is offside or it's not. So this is what we are going to come up with. We are going to look at some of these scenarios and under what circumstances or at what percentage will they say that that one is really offside. This one at least we can ignore. So because you have seen circumstances where you say as if someone is totally off, but they do not maybe they don't get the person, but they just continue with the match. So always these percentages have a say in the final decision. Then the last one is here. Someone can read for us and then we respond to it. Okay, Patricia.
Good morning, sir. Good morning.
Yes, morning, Patricia.
Okay. Sydney is a poultry farmer who raises local chicken, but has observed that 8 out of every 10 customers to her farm ask for broilers. Advise Sydney on what to do.
Okay. Okay, we shall. Patricia, do you want to say something?
Let me first think.
Okay. Yes, Rima?
Okay, so in this case, obviously she would have to be advised to rear some broilers because the majority of her customers are asking for them. If she failed to get them, then she would lose her business. Like she would lose the potential customers. She would not have a successful business. At this point, I'd advise her to get broilers because like the majority is asking for them. So if I would have to win, if I would have to be successful, I would have to do what they say.
Okay. Thank you. Okay. Me, I think one.
Yes, good morning, teacher.
Morning.
It's one Miguel. So I think Sydney is supposed to be advised to change to start rearing broilers because when you look at his probability, it is 80%, which is over the 50%, meaning it's on the likely side. So Sydney has to be advised to start layering broilers for her business to succeed.
Okay. Thank you. Thank you. I think gift.
Basically, I think he should rear more broilers than the local chicken, or he should also just choose to rear only broilers since the probability of the customers wanting the broilers is higher than the ones wanting the different kinds of chicken.
Okay, okay, good. I think the rest will agree. Like the main of you are saying, at least Sidin needs to go on and change to the broilers. Okay, and now my question is, do you think probability is good? Do you think you need to learn about it? So why do you think we may need to learn about probability? And why do you think probability maybe is important? How can maybe probability help you in your daily life? Yes, Samara.
Yes, teacher, I would say probability will help us maybe, most especially when you're dealing with business chances and most especially with the money rates, because in such cases you're going to have to make decisions based on the probability that it can be successful. Most especially maybe if you're dealing with the retail businesses or you're dealing with this arts and crafts business, you're not sure whether it can be successful or whether it will exceed. So it is most especially with the decision making you do, because you're looking at the numbers. Does it have a probability of success or it doesn't have that probability of success? That is
Okay,
my
and
take.
in business, that's what we call risk assessment. So
Yes.
probability is very crucial in the decision making, more so when you are assessing the risks for your particular business. Thank you, Amara. Yes, Rima.
Welcome, teacher.
Okay, sir, probability is essential in like, let me give a scenario. Let me say I'm now a Form 4 candidate and of course, I have to prepare for my examination. I have a chance right now. There's a probability that if I practice better right now, I'll have success later and receive it. So it helps me have hope and chance and believe in myself that I can use this time well and it will bring me a good outcome.
Okay, perfect. You can make predictions. Okay, good, depending on the efforts you are putting in. Okay, Pearl.
I think probability is essential. Like, for example, in business, you may not be sure if it will work out or if it will not work out. So it helps you just be prepared for anything, whether the rising or the fall of the business.
Okay, so it can help you to analyze information and data. Okay, good.
Yes.
Thank you, Pearl. Patricia.
Okay. First, in the aspect of you knowing that it's going to rain or not, probability helps you to prepare. Like, for example, if it's going to rain, you'll know when you've dried your crops, you'll have to first remove them from the compound since you see a chance of it raining. Then also, like for those who like football, like as we saw, the team had a three, it had already gone ahead by 3 goals, and another team was trying to catch up in 5 minutes. So it helps those who are ready, who know that they are winning, like like they already know that they are winning. It helps one to have that awareness that have already reached there. And this team, maybe they'll gain hope also or lose hope at that point.
Okay. Oh, thank you, Patricia. Then lastly, Karen.
So, good morning, everyone.
Good morning.
I think probability helps us to take caution. For example, like people who drive on roads, there is a very high probability that you can get into an accident and maybe die. So this will help you to like take the safety precautions, like fasten your seatbelt and so on.
Okay, true. Yes. Okay, thank you. So we are going to end on those ones. Then the rest, feel free to put them in the chat. Okay, now let's dive into our work today. Now I'm going to ask you to first do for me this activity. Let me hope everyone can access a coin where you are. In case you can get it. And I want you to draw a table in your book, a table of this nature, where you're going to put the toss number and the side the coin landed on. So just get a coin. It can be 100, it can be 500, it can be 200, a 1000 or a 50 shillings coin. Then after obtaining, let me know people have got them in case it is possible. But in case it's not possible, do not worry. Then after, you toss the coin and let it land on a flat surface. So let's take an example. I'm going to toss, in case for me, let me take the 100 coin that I have. Okay, let me also get mine here. So by tossing, you leave it to fall. So when I toss mine, so mine, the first toss I've obtained here, it has shown me a cow on top. I'm going to toss again. So you are going to toss, but for you, feel free to toss. So when I toss again, the second toss is showing me the coat of arm. So I want us to toss about 5 times and then fill in your table. Then at the later time, we are going to be referring to that table. Yeah, but after the lesson, I'll ask you to toss about 20 times and then fill that table. After the lesson, in your free time, you'll toss about 20 times, and then I want you to make an observation on the side the coin landed on when you have tossed very many times. But this was an activity that I wanted us to just try. But in case you are unable, at least make sure you have a coin around you because we are going to use it going forward. Now, I'm going to ask you, the first question is here. What are the possible sides a coin can land on? Looking at that coin you have, you can raise up your hand. You tell us the coin you have and the possible sides it has landed on. Okay, Chisache?
Yes. For me, I have a 200 coin. It has two sides. One side has a fish, and
Okay.
the other side has the coat of arms.
Okay. Coat of arm. So that this is the 200 coin. So those are the possible sides the coin can land on. Yes, Pearl?
So a 500 shilling coin.
500.
There is the side with the crested crane, the head of a crested crane.
Crested crane.
And the other side is having the coat of arms.
And the coat of arm. Okay. Good. Now, okay. Yes, in heads. Okay, good. Now, what do I want you to know? One is the possible sides a coin can land on. Now, in probability, we are going to be referring a lot to what we call the possible outcome. And always, going forward, whenever you find a fish will qualify to call it a head. So then your coat of arm is what we shall be calling the tail. The same thing happens that the front of a coin is what we call the head. So whenever you are dealing with coins, with tossing a coin, you are going to have two possible sides. You either have the fish or the coat of arm, but the front of the coin, always this one, is what we call the head. No matter what is there, whether it is a cow, whether it is a head of a crested crane, but always we shall refer to it as the head. Then the side that has the coat of arm is what we shall be calling the tail. So whenever you are tossing a coin, the two possible outcomes, like you have noticed here, you can only get a fish or coat of arm, crested coin or coat of arm. So it means that when we are dealing with coins or tossing a coin, the two possible outcomes, we shall not be saying fish and a coat of arm. Instead, we shall be calling them a head and a tail. Members, are we together on that point? Is that fine? Okay. Okay, so for you, whenever you are tossing a coin, we shall have a head and then a tail. So I'm going to ask you to first now write something in your books about probability. So whenever we are dealing with probability, we are looking at studying about things of chance, things that can occur, the likelihood of something occurring. Then we have what we call random. When we talk about a random, we are looking at those things that can occur without any predictable pattern. Take an example. You notice that in our table, when I was tossing my coin, the first time I tossed, I had a cow, of which the cow is what now we shall be calling the head. Then the second time I tossed, instead I got the coat of arm, which now I'm calling the tail. So this is what we call random. It is, you cannot predict what is going to happen next because you may toss again and still you get maybe a cow. You toss again, then you get a cow. You toss again, then you still get a cow. So you cannot predict. It is something random. So that is something that it can vary. You are not certain. So that's what we call a random experiment. So random means that even when we are carrying them out, when I tell you to toss a coin at your home, another one at their home, and another one at their home. We cannot have the same we cannot have the same pattern that all of you are having cow, or coat. No, you'll find that the first one may have a cow, another one may have a coat of arm, and a cow. So the pattern will always keep on changing depending on the someone who's chance. Okay. Then when we talk about an experiment is the action that you do in order for you to observe the outcome. Take an example. When I told you to toss a coin, we were performing an experiment. When I tell you to roll a dice, it means that you are performing an experiment. When I tell you to pick cards, it means that you are performing an experiment. So an experiment is anything that you do when you want to make some observation of what happens. In biology, physics, and chemistry, we call them experiment because there is something that you are going to be observing using your eyes. That maybe you look at the pendulum bulb, maybe you are looking at how the colors are changing, maybe you are looking at this and the other. So that's what we call an experiment. So in probability, we are always going to be doing experiments such that we can be able to observe the outcome of what we are doing. So whenever they talk about an experiment, we are looking at those actions, we are looking at those things that you are doing in order for you to be able to observe what is happening or what comes out from what you are doing. Okay. Okay. Some people are saying they are done. Okay, when you finish, okay, so far 2 people have said they are finished. Okay. We'll give them just some few minutes. Okay, I think we are good to continue. Okay, now we are going to look at how do we generate a sample space. Now, when they talk about a sample space, we are looking at all those possible outcomes you can get when you perform that experiment. When I told you to toss a coin, you note that the possible sample spaces were 2. So, those who are into soccer, always before the match starts, you have seen something of this nature happening, whereby the captain from one side comes with the captain on another side. And the reason why they come is for them to be able to make a decision which team is to start from this side and to start from this side. So what you are seeing here, the gentleman or the referee was tossing a coin such that you can know which side you are going to take on. So this is where we shall also apply our probability. Now we are going to generate our sample space. So when they talk about a sample space, they are looking at all those outcomes, all what you can observe when you perform that experiment. When we throw a coin up or when you flip a coin, what are the likely outcomes? What can you be able to observe? So we have 2 things. One, you can observe the fish or you can observe the coat of arm. There is nothing else that you can observe apart from those two. Whenever you throw your coin, those are what you get. So what does it mean? It means, like I've already told you, this is what we call our head, and then this is what we call our tail. So whenever we have a coin, the sample space I've said, that is everything you can observe when you carry on that experiment, all the possible outcomes. So when they ask for the sample space of a coin, the sample space of the coin, we always use these brackets. So you can either have a tail or a head. So these are the only things you can obtain. There is nothing else you can obtain. So this is what you call a sample space. But at also this moment, allow me to talk about what you call an event. When we talk about an event, this is a single outcome. This is a single outcome from the experiment. So for this particular one, in case it is a coin, an event can be a tail, an event can be maybe a head, a single outcome. Like when you throw your coin, what comes? That it is a head. That is what you call an event. But when you combine all the events, then you get what you call when you combine, the event is a subset of what we call our sample space. So an event always comes from a sample space. Members, let me know whether we have understood the difference between an event and what we call a sample space. Are we on the same page? Okay, we on the same. Okay, very good. Okay, we continue. Now, through the chat, can you tell me, I want everyone to list for me the sample space for this particular one I've displayed. Some of you love playing this game. What is the sample space for this? Sample space. Sure, I have not yet seen any answer that is correct. Now they are coming in. They are coming in. Yes, yes. Very good. Yes, yes. Okay. Yes. So when we talk about sample space, you list all what you can get. Remember, this is a dice. So when you throw it, you can either get a 1, this one here, or you can get a 2, you can get a 3, you can get a 4, you can get a 5, or you can get a 6. So whenever we ask for sample space, we expect you to list so when we talk about sample space, you must list everything you can get when you toss it. So you can get a 1, you can get a 2, you can get a 3, you can get a 4, you can get a 5, and you can get a 6. So this is what you call a sample space. Are we together, members? Now, we are going to talk about now an event. Now, I'm going to define my event. My event, you are going to put for me in the chat an event for an even number. An event for an even number. Type in the chat what you are going to write in your set of event that is an even number from that sample space. Okay. 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 Oh, Amara, where are you getting 8 and 10? Remember, an event must come from the sample space. So an event always comes from the sample space. So when you look at the numbers we have, the sample space we have 1, 2, 3, 4, 5, 6. So our event can only have numbers that are even. And even numbers, those are numbers that are divisible by it. So I'll have to pick only those ones. 2, 4, and 6. So that is what we call our event. Like I've told that always your event comes from the sample space. So anything you don't have within the sample space, you ignore it. Okay, give me this event. Event, it is a number less than 3. Number less than 3. What is your invent? Okay. Perfect. 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 Okay. 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 Very good. So that is how we get an event. So an event is a single outcome that we can specify, and then, but always we obtain it from the sample space. Okay. Now I'm going to continue a bit. Now, when I use n is going to be standing for the number. How many are they? Then when I write like this, it means that the number of elements within the sample space. So S at times represents the sample space, whenever you find S. So when I put N outside, it stands for the number of elements within the sample space. So Shekinah and I saw another person that was giving 6. It means that for you, we are giving the number of elements within the sample space. So let me ask you, for this particular event, this one, here, this one that I'm circling, give me the number of elements within the event and what you have as the number of elements within our sample space. You type in the chat again, and we see. The number of the events, very good. It is 3. Good. Then our sample space is 6. Okay, very good. Okay, okay. That is good. Now we are going to continue to try another one. I think some of you love playing this game. For this one, let me ask you. I may not ask you the sample space because actually it is very big, so we may not exhaust everything. But let me ask you, what is the number of elements within the sample space? Type in the chat if I want to see. But I've given you all the sample spaces, so feel free. 26, 54. Okay, mathematically, we shall not consider your jokers. So your jokers, I think we shall not consider them here mathematically. Okay. Okay, Sheldon, yes. Joy, yes. Amara, 14. Joshua, 52. Okay, yes. So I think many of you are noticing that we shall have the number of elements within the sample space. I mean that now you count how many cards are you seeing. So remember, a full deck will have all these cards. So you can count and say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then here I have 1, 2, 3, 4. So 13 times 4 will give us, I think it is 52. So here the number of elements within our sample space is going to be 52. I don't know whether that is very okay. Is that okay? Yeah, so you only please don't bring in the jokers unless when they have told you to do so. But here, mathematically, in our probabilities, we don't consider the jokers. So those who are mentioning 54, it is because you have added on those 2 jokers. But here, we shall not consider them. Now, let me hope. So I want you to tell me, what is I'm defining my E as my invent. And here, I'm saying queens. Let more people know the queens. So what is the number of invent for the queen? Hope people know the queen. 12, 4, 4, 4. Okay, 12, 12. Okay, 4. Okay, may someone raise up the hand and maybe makes us understand more about the queen, or what is the queen? Yes, Amara?
So, teacher, as you play, okay, when you're playing Matatu, or like when you're playing with cards, so the queen is usually the one that has a symbol of, let me say, Q.
Q,
So,
So
now
Q,
the queen, yes.
This one, eh?
Yes, teacher. So, now it's in 4 possibilities. First, it's in the side of flowers. It's in spades. it's in
Mm-hmm.
hearts, and it's in
Mm-hmm.
diamonds. So when you
Okay.
asked us when you asked us the event of the number of queens
Mm.
would have to be 4
Okay.
specifically.
Okay. Is it possible to tell us the other names, how they call these Ks, the Gs? Do they have specific names, you know?
I would say that for the K, it's king, basically. It's the
This
king.
is King. Uh-huh.
Then for J, I don't know how I can say it, but usually now, in most of those times, they would say those are the jesters.
Just as, okay.
Yes.
Then the S.
Then the A's are the aces.
Uh-huh. Okay. So please make sure you are familiar with that kind of knowledge when it comes to cards, because the questions may ask you queens, may ask you now kings and the rest of that. But in case they ask for numbers, then those ones are easy for you to obtain. Members, are we still together on sample space? Uh-huh. Someone's told us, I think, A's are the ones that are called. I've seen this. Then G, they're telling us they're called. Someone is saying this, Joel, another is saying Jack. I don't know which one is correct, but I know you need to just know. Yes. Okay. Okay. Yeah. So you should have those names within your head because in case Jester, someone is saying Jester. Okay. Jack. Okay, I think it's somewhere there. So you can make research and find out the actual names. Okay, hope we are still together. Now let us continue. I think also you have seen such games in betting, those who are risking and doing some betting. You have seen such machines. So these machines are also doing things on probability, and we are going to be looking at how they spin and the chances of you winning whenever you put your bet there. Okay, so let me ask you now to write about what we call a sample space and an event. You finish, you let me know. Okay, I think people have finished. So when you find S, capital S will be standing for sample space. And when it comes to an event will represent it by an E, a capital E. Okay, then we are going to write this as well, the formula. So in order for us to get our probability, always we get the number of events, which we have represented by NE, out of the number of the sample spaces. So that's how we get our probability. So we get the event divided by the sample space. Seems people have finished according to what I'm seeing in the chat. According to what, okay, done. Okay, I think we are good to start doing some examples. Okay, I think you can as well summarize this, what we call the probability scale. And I want now from here to let you know that one, in the whole of this topic, you will never have an answer below 0 and above 1. So any answer, whenever you are making your calculations, your smallest answer you can get is 0. So our probability will always lie between 0 less or equals to the probability less or equal to 1. So your answer should be within that range between 0 and 1. So you can never get an answer, let me say 1 point something. Whenever you find yourself getting such answers, just know you are wrong. You can never have negatives. The moment you see yourself with a negative, just know you are wrong. So when we talk about probabilities can be represented in 3 ways. You can represent it as a fraction, like the first one, can be represented as decimals, like what you are seeing here, but also can be represented as percentage. So this can be 0%, this is 25%, this is 50%, and this is 75%, and this is 100%. So now it depends on how the question is set. Some questions you'll find them using fractions. Some questions they'll use decimals. Some questions they can use percentages. So probability can be represented in any of those things. So one, you need to know when you score a 50, it means you have equal chances. So whenever you score a 50 in a paper, it means that there are chances that it was just by luck, it was by chance that you got the 50. But either you were slightly going to be above or you were going to be below. But when you get something above 50, that one is an indicator that at least there is some kind of understanding in what you have done. But whenever you find yourself getting below 50, it is just an indicator that there is still some work to be done in that paper or in that subject. But whenever you get a 50, it means that you are at least on a track. That's why always they encourage you that make sure at least you score 50 and above. 50 and above. It means that at least you are above the average. So that is how our probabilities are going to be. So it doesn't matter whether it is in percentages, whether it is in decimals or fractions. But whenever they give you in percentages, then always better you write also your answers in percentage. They give it to you in decimals, you write your answer in decimals. They give you in fraction, then you go on and write your answers in fractions. Okay, are we good to continue? Okay. 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 Then some people have finished. So in case you have not finished, you can take a screenshot. But the most important thing is for you to have put them in your head. That is what is really very important. Okay. 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 Now we have our first activity here. I'm going to do for you one activity, then the rest we are going to do them. You're going to do them. So we have an activity. They're telling us that 2 coins are tossed. Obtain the sample space by using a table and a tree diagram. So like we have said that when it comes to our coins, we shall always have our head and we shall have what we call a tail. Now, let me first test you in the chat. Can you tell me all the possible outcomes that you think we can obtain? Imagine you are tossing two coins. You are tossing two coins simultaneously together in the chat. First put for me what you think we are going to have as our possible outcomes. Remember, we have said we are using coins, so I expect you to write for me head, tail, but we can represent H and T. Head and tail, head and tail. Okay. Now, allow me to say that we are going to represent, let our heads be represented by H, and let the tail be represented by capital T. So I'm going to first use the table. Now, under the table approach, I'm going to have these two things. Remember, you are tossing two coins. So when you toss the coins, this is the coin. Like I've told you, this is even a head. So when you look at these two coins, these are two different coins. So when I toss them together, all of them can fall on the ground and I have a head and a head. So I'm going to say this is a head and a tail. This is a head and a tail. So this is what I'm going to call my first coin. And this one is going to be my second coin. So when I toss, chances are there that I can have a head and a head. So this one can be a head and a head. But still I can have a head and a tail. So here I can have my head and I can have my tail. But chances are that I can have for the second coin, when the tail is the first, then the first coin shows me a head. Or I can have a tail and then I have what? A tail. So tail means that the first coin, maybe the second coin is having a tail and the first coin is having a tail. This one means the second coin has a head and the first coin has a tail. So meaning that our sample space, what we are going to be calling our sample space, which I'm calling S, is going to be equal to what can we obtain? So we have noticed that we can obtain a head and a head and a tail and a head, and a tail and a tail. So in our sample space, we shall say we can have a head and a head, we can have a head and a tail, we can have a tail and a head, and we can have a tail and a tail. Members, let me know whether we have understood that point. Are we there on that point? Let me know. Okay, Favor is there and Mujun is there. Okay. Yes, Karen. Okay. Very good. Okay. I think we're on the same page. Okay. Sheldon is there. Colin is there. Okay, good. Okay, now that is how. Okay, now, Virginia, it came from the question. They told us that two coins are tossed. So it is coming from the question. Two coins are tossed. So that's why we are using the two coins. So here I mean like you have two coins in your hand and you throw them up. So when they fall, there is a chance that the first coin can show you a head while the second one also shows you a head. There are chances the first one can show you a head, another one shows you a tail. Hope Virginia, we are together on that. Okay. Now put for me in the chat, what is going to be the number of sample space? Number of sample space. Very good. So our number of sample space here is going to be 4. So you just count them, how many they are. So I have 1, I have 2, I have 3, I have 4. Okay, now this is when we are using a table. Now, what about when we're using a tree diagram? How do we go about it? Now, under the tree diagram, you know how a tree, some of the features on a tree, one, a tree must have branches. You know very well that when there's not many of the trees we shall have, you have a tree, and this is my tree. which has some branches going somewhere. So also when they talk about a tree diagram, it will have those trees. Now what happens is that when we are tossing, we know very well that a coin, this is going to be my first coin. Now, under my first coin, it has two parts. It has a head and it has a tail. So when I'm tossing it, okay, okay. So when you are tossing the coin, okay, let me not put here there. Let me first remove this. Now, these are your these are your coins inside. So when you have your coins, maybe, and you are tossing them, what was going to happen? One, these are your coins. So let me assume these are your coins. You have put them inside, maybe, you have put them inside something, whereby maybe one has here a head, another one has a tail. So when even if you don't look at what is inside, but for you have put them. So what does it mean? That when you throw it down, one, there are chances that this coin is going to give you a head, or it can give you a tail. That is the first opportunity. When you toss it again, or when you toss it, there are chances that it can give you a head, it can give you a tail. Or for this side here, it can give you a tail and it can give you a head. Something like that. What does it mean? But this one, allow me to introduce tree diagrams at a later stage. Let me introduce it later. But still you get the same answer. You'll get a head and a head, a head and a tail and a tail, and a tail and a head. But allow me, I will introduce them later. Let's first leave it at that. Okay, I first go to the second number that I wanted us to do. Now I have dice here, and they are 2 in number. I'm going to ask you to first put for me I don't want you to complete the sample space, but first give me in the chat briefly to see whether people will be able to get the sample space. Just test me inside in the chat there. So at least give me 2 sample spaces you expect to get when you have the 2 dice. Okay. 3, 4, 1, 2, 3, 4, something like that. Very good. So for us to be able to do it still here, we are going to use the table. So I'm going to come up with the table, but you are going to complete it yourselves. For me, I'm going to just show you. This is our first dice here. This is the second one. So you know that a dice has how many sides? Has 6. So it has a 1, it has a 2, it has a 3, it has a 4, it has a 5, and it has a 6. That is the first one. Since you have 2, there is the second one here, which has a 1, which has a 2, which has a 3, which has a 4, which has a 5, and which has a 6. So this is my table. So I'm going to ask everyone to complete the table on your own. It's going to be like that. That is my table. Hope everyone has understood how we are drawing our table. You have the 2. This is the 1. This is what I'm calling the first dice. This is what I'm calling the second dice. So the first one, I'm giving you just 1. The rest you complete them. We are going to complete. So the first one, I can have a 1 and a 1. I can have a 1 and a 2. I can have a 1 and a 3. I can have a 1 and a 4. I can have a 1 and a 5. Here you can have a 2 and 1. Can we complete the table on our own? we are completing the table. We are okay. We are completing the table. Okay. You let me know through the chat whether we have finished. Okay, Fantas has finished. Okay, people have finished. Now I'm going to ask you, yes, what is the number of sample space? Yeah, what is the number of sample space? Okay, Such has told us that 36, 36, 36. Okay, very good. There are 36. Now, when they ask you to list the numbers, please you must come up with them. So you come up and say 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, like that. Yeah, but good enough. Now you know how to generate. Okay. Let us look at another one. Let me ask you to write in the chat what you think. You can draw your table, no problem. You can draw your table, no problem. Yes, you can draw your table for this sample space and then write them down. Or you can write for us in the chat what you're getting. So this one is for you to try out. We are generating a sample space. I'm seeing some answers coming in the chat. It is 20. People are getting 20, others 30. Okay. Can I choose? I saw Sheldon typing. Sheldon,
Yes, please, Chair.
how was your table? How did you come up with that answer?
I first drew a table.
Mhm.
Then one side I named it first spin.
Mhm.
Then no, on top.
On top, eh? Okay.
Yes. Then the side second spin.
Mhm.
Then first spin I said A B C D.
A, B, C, and D. Mhm.
Second spin 1, 2, 3, 4, 5.
1, 2, 3, 4, and 5. Okay.
First column A1, A2,
Mhm.
A3, A4, A5. Second column B1, B2, B3, B4, B5. Third column C1, C2, C3, C4, C5. Fourth column D2, D3, D4, D5. Then I counted the
number.
space, then I got 20. 4
Okay.
times 5 equals 20. Yes.
Okay, 4 times 5 is equal to 20. Okay, good. Please let me hope that is what you have done for this particular number. So that's how I expected you. And when you're concluding your sample space, you write everything you have come up with. So from here, I want to define my event. Where my event, I'm going to say, having the first spin with A. So what will you list in that sample space? Linda? Linda?
Good morning.
Oh, sorry.
Good morning, sir.
Morning.
So for me, okay, my sample spaces were like 1A, 2A. So I don't know whether I'm correct.
Yeah, you are correct, Linda. That is very fine.
Okay, sir.
Okay. Yes, Olive?
Okay, for me, I'm going to read the number of events having the first spin with A. That's A1.
A1.
A1. A2.
A2.
A1, A2, A3. A4 and A5.
A5. Very good. Very good. Yeah. And okay, thank you. And the same way you see these things unfolding, when they are working on those machines, those betting machines, this is still they use some kind of pattern, they use some kind of sample space. So you'll find that they have quite a number of them, So like when you look here, you cannot, they have, I think, up to 30 what or 36. They are very many. So meaning that for you to win, always, you are not saying that they have the numbers. Now for them, they have 1 to 36. Okay, the highest I've seen so far is 36. Then they have letters A, B, C, D, E, F. A, B, C, D, E, F. Now, remember here your sample space will be A1, A2, A3, A4, up to A36. After that, you go to B1 up to 36. You go to C up to 36. You go to D like that. So the sample space is really very, very big. But for you to land, now when they are putting the winning things, they make it in a way that it has some kind of rotation. And they always target a given number or a given sample space that maybe it will be at A2, of which even they can program it that after maybe some time, after maybe 3 or 4 times, it is here, like that, like that. So that's why when you're going in for these things, sometimes it can take you a lot of time for you even to just win. So that's why for them, they will keep on collecting the money, collecting the money. Chances are there are people who are really lucky that can go on for their first time and win. But sometimes it needs you to go through a lot in order for you to land on that kind of sample space that they place the money on. So that is how the betting. So the betting has a lot of these sample space things that you have to land on in order for you to know where you are going to place. Okay. So that is one. Now what is going to happen? You are going to do for me number one. You are doing for me number one. Yes, Dega Dash.
Good morning, sir.
Yes,
I
good morning.
joined a bit late and I have a question to ask.
Okay.
Is there possible to then maybe giving you 3 tables and the sample space?
Yes, it is very possible.
How do you draw the sample space?
Now, for that one, you first obtain the sample space for 2, and then after you combine. I'm going to show you, take an example. In case they say maybe, okay, let me say coins. So you know that the sample space of 2 coins, we shall have a head and a head, head, tail, tail or head, and maybe tail, tail. This is for 2 coins. So what you do, you draw your table where you have the sample space for 2 head, 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 tail, tail or head, and tail, tail. So these are 2 coins. So then you add on a third one. Let me say this is the third coin, which has a head and then it has a tail. Then you start head, 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 tail. Have you got it?
Yes. Thank you,
Yeah.
sir.
Okay. So I'm waiting to look at the sample space of your part B. Sample space, Hunter is getting 12 and the invent is 1. Okay, the sample space people are getting 12. 12. Okay. Okay, and then the probability, people are getting 1 out of 12. Okay, sample space is 12. If you are getting that, that is very good. Sample space, people are getting 12. And the event that a head and a 1 show up. Now here, please do not forget, we have a die and a coin. So this is my coin, a head and a tail. Then I have 1, 2, 3, 4, 5, and 6. So I expect you to have a head and a 1. So for it to show up, it means that in our event, we shall only have a head and 1. So this is just one outcome. So that's why you'll say 1 out of 12. So let me ask you to take a screenshot. Yes, 1.
Yes, teacher. I'm asking now, what if ours is our tables are drawn vice versa? For example, this one of yours where you have H and T, it's where I've indicated my figures of 1, 2, 3, and 6. Is it also okay?
Very, very okay. Very, very okay.
It's okay.
Okay. So take a screenshot. Take a screenshot. Hope members have finished to take a screenshot. Unfortunately, this week, I have quite a number of presentations to make at the Innovation Hub. So we are going to be ending at 6:30 to enable me to go a bit early because I must start those presentations as early as 8. So I need to move. So we shall be ending at, if at worst, 6:45. But today, being the first day, I won't be there on time. So we are going to end at this point. But in case you have a... Yes, Virginia.
Sorry, teacher, but I didn't understand how to conclude part B.
Part B, eh? Oh, now, when you look at part B, they ask you the event that a head and a 1 show up. So looking at your sample space, you notice that you have where you have a head and a 1, eh? Not so? So here, your number of event will be equal to 1. Is that okay? Because this is just one outcome. Then, in order for you to calculate probability of the event, we have said that probability of the event will equal to the number of elements within the event divided by the number of elements within the sample space. So your event has a 1 divided by the number of elements in the sample space. So when you count, you notice you have 12. So you will just leave your answers 1 out of 12. Is that fine?
Teacher.
Okay.
Yes, teacher.
Okay. Okay, allow me to display other questions that you'll try out. Yeah. Okay, hope members have taken a screenshot. Okay, so we are going to end here and then we shall again meet at 2 for functions. So at 2 we shall be looking at functions. Yes, so make sure you come on a bit early because I'm also planning that for that lesson we shall do at least 1 hour. 1 hour and maybe 15 or 30 minutes. Yes. So, but tomorrow we shall meet. But I know after tomorrow we can finish at around 6:45. Okay. Thank you so much for attending. Hope you have taken a screenshot of these numbers that you can try out. Don't go back to bed. You can try out and finish them. Then you can share them on WhatsApp. I can be able to look there once I get the time. Thank you so much. Have a lovely day, everyone, and bye-bye.
Bye.
Bye.
Okay,
Bye.
bye. Bye, bye, bye.
Bye.